Okay, section 7.3, we're going to focus only on the discriminant here, which is this little piece of the quadratic formula. What they do, I got it set up to save time. They give us the first 4 examples to show our different scenarios of our possible answers, our possible outcomes when we're dealing with a discriminant. So, what we have is, with this piece, our A is 1, our B is -3, and our C is -40. So we have the square root of B squared, so it doesn't matter if it's a negative, we're squaring it. We're only focused on this piece now. So we have 9, and we're taking -4AC. So -4 times 1 is -4. -4 times -40 is positive 160. In this case, we have square root of 169, which is 13. However, we know that we have plus or minus 13. So we have two possible rational solutions when we have a perfect square. We know we're going to get a number out of there. The only difference is, instead of saying it's a perfect square of 13 with 13 as the root, we have to say plus or minus. So it gives us our 2, plus 13 or -13, positive 13 or -13. So 2 rational solutions when we go this route. This one, our A is 2, B is -3, and C is 4. So we do the same thing. Again, only concerned with the discriminant, this piece under the radical symbol. So I have B squared. So again, I have 9. They like that. So I have 9, and then minus 4AC. 4 times A, which is 2, is 8, times 4 is 32. Those are both positive. So 9 minus 32. So now, in this case, what's going to end up happening, as you already see, there's going to be a negative. When we have a negative, excuse me, when we have a negative, you already know that we are going to end up with an I. When we have an I, we're talking complex. You automatically know as well that we're going to have a positive or negative. So we're going to have a -23 here. We're going to have plus or minus, since it's square root, but I have to pull out an I. I need to pull out an I. Because I have a negative. So whenever you have a negative in the discriminant, you are going to have 2 complex solutions. So, and we don't have to finish some of these, you just have to get to a point to know what's going to happen. Here we have A equals 4, B equals -12, and C equals 9. So we have our square root. We have B squared, which is 144, minus 4AC. And I'm going to cheat real quick. Whoa, which oddly enough, 4AC gives us 144. So we have 144 minus 144. Square root of 0 is 0. There is no positive or negative. So here we get one rational. This will play a role in the future. With example, might be example 6, I think, or no, example 5. It gets to where it's going to ask us for one rational. We know this is the only time we get one rational solution, is when it's square root of 0. Then down here for example 4, A equals 1, B equals 6, C equals -8, because I would move it, remember, I would move the 8 over here to set equal to 0. So what I have now is b squared, 36, minus 4ac. 4 times 1 is 4. Negative 4 times negative 8 gives me a positive 32. Square root of 68. And we don't even have to at this point, but we could break this down. And you know, square root of 68, if we were to divide by 4, we could divide by 4 and bring a 2 out. But either way, when you get to this point and there's not a perfect square, you're going to have two irrational solutions. So this is what we're talking about. When they discuss the discriminant, we only take that piece of the quadratic formula and we answer only that piece. We don't worry about the beginning and we don't worry about the denominator. We just want to see what answers are we going to have, what types of solutions will we get. And I'm doing all right on time, so I am going to go to the next example. I'm going to leave this up just to give you a reminder while we're working the problems of our possible solutions. Now, the first problems in the problem set, I believe, just ask what your solutions will be, how many and how will they look. So that's all they want. When you get to this point, you don't really even have to answer it. If you know there's a perfect square, you have two rationals. If there's a negative, you know you're going to have two complex because you have to pull an I out. If it's 0, it's one rational. It's the only time you have one rational. And if it's going to leave you with something in there, it's not a perfect square, but it's not negative, you have two irrational solutions. So example 5, and we'll see how we're doing for time. I plan on breaking this in 2 videos, but I might not have to. Example 5 says, find an appropriate k so that the equation, and they give us 4x squared minus kx equals -9, has exactly one rational solution. So first, we have to write this thing in the form that we're used to so that we can use our quadratic formula, because we want to use our quadratic formula that has our discriminant, because that's how we know this answer. So we rewrite it as 4x squared, and now what we have is, I have an a, I'll write it this way, I have a b. My b is a variable. My b is -k, because remember, this will be our only variable, because my a is 4, my c is going to be 9, so I'm just going to be solving for k. Okay, so again, they want us to find an appropriate k. Find an appropriate k so that the equation has exactly one rational solution. So for one rational solution, here's our key. We know that the discriminant b squared, our discriminant is b, -k, so k squared minus 4ac, so which is kind of a nasty, oh again, it gives us 144. Square root of k squared minus 144, that equals 0. When that equals 0, I have one rational solution. The problem, example 5, says so that this equation has only or exactly one rational solution. So in order to get that, we get to this piece here. Well, you might ask, excuse me. So you might ask, what do we do now? Well, I set this up. The discriminant is inside here. The discriminant is this, what we're talking about here. We need to know, when does this piece, equal 0? Because the square root of 0 equals 0. So I need to find out how do I make that equal 0. So what I can do is pull this piece out, set it equal to 0. I add 144. I have k squared equals 144. Now I go back and use information that I learned earlier. I know that I can take the square root of both sides to get 1k. The square root of 144 is 12. So k equals plus or minus 12. For example 5. I think we have time. We do. I'm going to do the last couple examples. We'll get this all done in one video. So for example 5, we just need to go, they could say so that it has two rational solutions. You know what you're looking for in a way. But when they say one rational, we can actually solve it because we have to get 0. We know we're solving to make this, to make the discriminant equal 0. Here's the discriminant. I need square root of 0 equal to 0. So I need to figure out how to make that piece equal 0. K equals plus or minus 12. Okay. I thought I was going to have to split this up, but we can go for it. I think we can fit this all in one video. There's only 2 more examples left. Building equations from their solutions. And I think they start out with an example. They say if x equals 0, or if x equals 3, if x equals 3, if that was a solution, then we could say x minus 3 equals 0. Because remember, you could have that quantity, quantity times a quantity we're talking about. Then, what's the other one? X, if they say x equals negative 2, if x equals negative 2, we could say that. If x equals negative 2, then we know x plus 2 equals 0. Because if x is negative 2, negative 2 plus 2 equals 0. If x is 3, 3 minus 3 equals 0. You can set that up. Well, then you also know, we know their product is 0 as well. That times that. So in examples 6 and 7, when they give us a value, we can set up a quantity. And we can multiply together. So example 6. Example 6 says, find an equation that has solutions t equal 5, t equals negative 5, and t equals 3, positive 3. Okay. Remember the wording. Don't get too confused with this. Make it easy. This is easy. Example 6 is easy. Find an equation. We just want an equation set up that has solutions t equals 5, negative 5, 3. We know that to make an equation, we can set these up so they're equal to 0. If each one is equal to 0, we can multiply them together and our whole result is 0. So then you just start and do the opposite. If t is equal to 5, then I put a negative 5 in there. T minus 5 is 0. If t is equal to negative 5, I throw a positive 5 in. I should have left myself more room. And if t is equal to 3, I do the opposite. Now, I just go left to right, or if you see something, I'm just going to go left to right. I have a plus or minus. I know the middle term drops out. I have t squared plus 5t minus 5t minus 25 times t minus 3 equals 0. Well, then I just keep going. T squared times t is t cubed minus 3 times t squared minus 25t plus 75 equals 0. That's an equation. I'm done. They asked me for an equation. I have one. That's as far as I go now. Let me go over here. I can probably fit the other example in right next to it. So now, what are they going to give us? Example 7. Example 7 says find an equation with solutions. X equals negative 2/3 and I'll just say and 4/5. Now you could, hopefully you already know how to do these. you know that it's going to be opposite in between there. But now we don't just have an x. We have 3x. Remember, we work backward. If we had 3x equals -2, well then, to get 1x, we divide by 3. So we put this up here. Then I have the opposite. It's negative, I need a positive, and I'm left with 2. I'm going to do 2 different pieces here. That's this first piece. 3x plus 2 equals 0. That's that, because I would subtract the 2 over here and get -2. I would divide by 3 to get 1x. I'd have -2 over 3. So then this piece would be 5x minus 4 equals 0, because I would move my 4 and get +4, divide by 5, I'd have 4/5. So now what I have to do is take my 3x plus 2, multiply my 5x minus 4, set this puppy equal to 0. Okay, I'm running out of battery life, so hopefully I get through the whole thing. 15x squared, here I have a minus 12x plus 10x, so minus 2x minus 8 equals 0. There's my equation. 3x times 5x is 15x squared. 3x minus 4 times minus 4 is -12x plus 10x. That gives me -2x, +2, -4, -8, and I leave it. I'm done. There's my answer for that one. I hope you enjoyed this. We got through the whole section in one video. I didn't think we would. I'm glad we did. Let me know if you have questions.